Now, see here, this is the next topic where we have to discuss about work done to lift a rod. Okay. So in the previous case, we have discussed what is the work done to lift a pendulum. Huh? Now we have to find out what is the work done to lift a rod. Hmm? So let us take this is a rigid support, and I am considering one rod. This is one rod. Okay. So this is the center of curvature of a rod. Okay. So this is a rod which has been lifted to an angle theta. If it was a rope or a string connected to the pendulum, what did we do? If it is a rope connected to the pendulum, what did we do? We have taken this height. Am I right or not? We have taken this height. This is angle theta L. This is L cos theta we have taken, and this total length is L. Okay, we have written H is equal to L minus L cos theta. H is equal to L minus L cos theta. This is a rope connected to a ball or a string connected to a bob. But this is a different case. Rod you have taken. Rod you have taken. Rod means uniformly distributed body. Uniformly distributed body. For that, you have to consider center of mass. Hmm? Here, all mass is in the brass bob. This is massless. Then you have to consider the center of mass of this. But here, as it is a uniformly distributed body, a rod, we should consider the reference point as a center of mass. So now the center of mass is lifted. Okay, so what is happening? This center of mass is lifted from here to here. So what is this? This is called as half of the rod. From here to here, this is called as half of the rod. Okay. Now, what is the total height? This is the height. If this is L by 2, what is this? L by 2 cos theta. This is L by 2 means this is L by 2 cos theta. You have to find out H, and from here to here, this is L by 2. Am I right or not? Understood all of you? This is going to be the height. You have to take the reference point as center of mass now. For all uniformly distributed bodies, center of mass is considered as reference point. This is not uniformly distributed body, so I have taken the center of mass of a bob as a reference point. And that height should be measured from down to this reference point. But here height is measured from this center of mass to this center of mass after lifting. So that is going to be height h. So how will you find out height h here? L by 2 minus h కావాలంటే ఏం చేయాలి? L by 2 minus L by 2 cos theta. L by 2 cos theta. So h is equal to L by 2, if you common out, 1 minus cos theta. 1 minus cos theta. Understood? Everything is same. Here also you take h is equal to L. This is total h means total length minus L cos theta. Okay. So h is equal to L into 1 minus cos theta. Instead of L, for a rod, when a rod is hanging from a rigid support like this, you have lifted a rod like this. How much work you have done to lift the rod upwards? So for that, which height you have to measure? You have to measure the height of a center of mass. So there is a simple difference. So what is the work done now? Work done, you know the general formula is mgh. So in this case, you have to consider mg into h. H means L by 2 into 1 minus cos theta. Understood? So let us take one small example and solve the problem. Let us take one small example and solve the problem here. This is for a pendulum. This is just for reference to understand I have drawn here. But main concept is this one only for rod. So let us consider the length of a rod is given as 2 meters and mass of the rod is given as 2 kg. G is considered as 10 here and is asking us to find out what is the work done to lift a rod through an angle of 60 degrees. Through an angle of 60 degrees. How much the work you have done to lift to an angle of 60 degrees. So what is the formula you will write? Just W is equal to M. M means 2, G means 10. Length of the rod is 2. Because of center of mass you have taken, you are right, 2 by 2 into 1 minus cos 60. So 2 gets cancelled. W is equal to 20. 1 minus cos 60 is 1 by 2. 1 minus 1 by 2. So W is equal to 20. 1 minus 1 by 2 is 1 by 2, which is nothing but 10 joules is your answer. 10 joules is your answer. For example, you have lifted this rod to an angle of 90 degrees. It was vertical, you made it horizontal. What is the work done by you? A simple logic here. So W is equal to same formula. Up to here it is same. 20 work same. But what is 1 minus cos 90? Cos 90 is how much? 0. Cos 90 is 0. So W is equal to how much? Answer is 20 joules only. Understand? So to lift from vertical to 60 degrees, work done is how much? 10 joules. To lift from vertical to 90 degrees, work done is double, 20 joules. Is it clear? Understood all of you? Okay. So this is one concept. Next concept is, for example, this is an inclined plane. This is an inclined plane. Length of an inclined plane is L. Height of an inclined plane is H. And there is one block placed here whose initial velocity is 0. Okay. It came up to here. From there to here it came. From there to here it came. Understand? So what is the work done by gravitational force to bring that block from top position to downward position? What is the work done? What is the work done? Let us take this length as 20 centimeters. Let us length you consider as 2 meters. See the inclined plane length, I am taking this length. This height I am not taking. This length I am taking. This I am taking as 30 degrees. Okay. So what is the work done by gravitational force to take this block from top to bottom? What is the work done? How do you find out the work done? See all of you, for finding the work done, the simple logic you have to use here is, you have to consider an inclined plane. I am taking a block here. First of all, I will decide which force is bringing the block downwards. Okay, what is that force which is bringing that block downwards like this? So I will find out that force. See here, this is a block which is considered as mg, and this is considered as normal reaction. Exactly in this direction, this is theta. And what is this? Mg cos theta. And what is this? Mg sin theta. So this is the force which is bringing the block downwards. Which force is bringing the block on the inclined plane? Mg sin theta. And you all know work done by gravitational force is nothing but the resultant force into displacement. The general formula for work done is force into displacement. But what is that force which is bringing that block? So W. So work done by gravity is Fr. Resultant force is mg sin theta, which is pulling downwards. So we write this as mg sin theta into displacement is L. Understood? So this is the formula you have to use. This is the formula you have to use now. Okay. For example, if the mass of the block is 2 kg, G is 10 meter per second square. Okay. So length of the wedge is taken as 2 meters. So what is the formula you will apply now? So work done by gravity is, mass is how much? 2. G is 10. Sin 30 is how much? 1 by 2. And what is the length of the slope? 2 meters. So 2 gets cancelled. So work done by gravity is how much? 20 joules. Is it understood what I am saying now? Huh? So that is the work done. And what type of inclined plane it is? It is a smooth inclined plane. It is a smooth inclined plane. If it was a rough inclined plane, what happens? If it was a rough inclined plane, what happens? What is the formula for that? So, work done by rough inclined plane, let us see. Angle theta. This is the block. Here, mg, normal reaction. Mg. This is theta. Adjacent to angle theta, mg cos theta. In this direction, mg sin theta. And friction is present here. Friction means F in the opposite direction. Understood? Friction is present here. And you all know that normal reaction in the upward direction is exactly equal to how much? Mg cos theta. N equal to mg cos theta. And you also know friction is going to be mu into n. The general formula for friction. It is going to be the general formula for friction. So here, what is the frictional force now? Mu into n means mg cos theta. So in this direction, what is acting now? Mu mg cos theta is acting. Mg sin theta is acting. Mu mg cos theta is acting. Both are acting, but the body is coming downwards. But the block is coming downwards. The block is moving in this direction with a resultant force. Then what is going to be your resultant force? Resultant force is how much here? See, resultant force is, this is dominating force, which is mg sin theta, minus that is the force which is on the other side. So mu mg cos theta. So I got the resultant force. Then what is the work done? Work done is resultant force into displacement. So for that, work done is equal to resultant force, which is nothing but mg. If you common out here, how much is left? Sin theta minus mu cos theta. Okay, this is the force. And displacement is how much? Length of the slope is the displacement. This is going to be the displacement. Okay, so finally you are getting how much? This mg multiplied with L is going to be mgl, and this is going to be sin theta minus mu cos theta. Okay, so this is going to be the work done by gravitational force when the surface is rough. When the surface is rough. No rough is here. See, uh, there is a ladder. Okay, and what is there? There is one wall. And this is the ground. This is the ground. Understand? So what you have to do? You have to lift this ladder and keep on the wall. This is a wall. Okay. What you have to do? This ladder you have to lift and keep Okay, so this ladder which was resting on the ground, you lifted and placed on the wall. What is the work done by you? You have to find out. So this is also uniformly distributed body. Hmm? Mass is distributed along the length, no? So this type of bodies also you have to consider center of mass. This one here, and from here you have to draw one line, and that is going to be the height h here. If the length of a ladder is taken as L here, so this is going to be L by 2, and this is going to be angle theta. Okay, so this is theta. As it is a uniformly distributed body, you have to consider center of mass, exactly center of this ladder here. So it was here and it has been lifted to certain height h here. That height you have to find out now. Okay. So what is, how can you find out that height here? For that, what will you do? Opposite side is the height and hypotenuse is the half of the length. So here you can write sine theta is equal to height h by hypotenuse, which is taken as L by 2. So h is equal to L by 2 sine theta. And what is the general formula for work done? Work done is nothing but mgh. So W is equal to m into g into h, which is nothing but L by 2 sine theta. So this is going to be your formula. Understand? So if the mass of a ladder is 2 kg and length of the ladder is 5 meters, length of a ladder is 5 meters, it has been lifted to an angle of 30 degrees like this. 30 degrees like this. So what is the work done by you? The formula for that is ready. So W is equal to mass of the ladder is how much? 2. G is 10. Length is how much? 5 meters. Means 5 by 2. Sine 30 is 1 by 2. Understand? So 2 gets cancelled. 2 ones, 2 fives. So W is equal to 5 fives are 25 joules is your answer. Understood what I am saying? Is it clear? So this is one concept. Now the next concept is, let us imagine there is a table. There is a, this is a table here. On this table, there is a chain, and some part of the chain is hanging downwards. Some part of the chain is hanging downwards. So total length of the chain is L. Total length of the chain is L. In that total length of the chain, some amount of chain is hanging. Okay. So how much amount of chain is hanging? Let us see here now. So let us take 1 by nth part of a chain is hanging. L by nth part is hanging here. Understand? So what is the mass of the chain which is hanging now? Is it not m by nth? Because total mass of the chain is considered to be m. If L by nth part is hanging, m by nth part is also hanging. So you can take in the place of n2. 2 means m by 2. Half of the chain is hanging. M means L by 2. Half of the chain is hanging. Understood? So need not confuse m by n. If you take is m here, m by 2 and L by 2 hanging part. But this is a uniformly distributed body. Chain is also uniformly distributed body. So you have to consider the center of mass of the chain. Okay. So what is the mass here? Just see. See, mass of the hanging chain is m by n. Okay. Height of the hanging chain, you should not consider n by n. You have to consider only 50% of the chain, half of the chain, because this is going to be the center of mass, center of the chain. So you have to consider L by n divided by 2, which is taken as height of the hanging chain is L by 2n. Understood? So what is the work done by you to pull the chain? Okay. So what is the work done here? So which is nothing but mass of the hanging chain, G into length of the hanging chain. So what do you get from this? What do you get from this? What is the formula getting from this? So work done to pull the chain is nothing but mass of the hanging chain is how much? M by n. See, the formula is mass of the hanging chain, which is m by n into G Length of the hanging chain is, you should not take L by N, you should take center of mass. L by N, half of L by N is L by 2N. So L by 2N is the answer. So work done to pull the chain is nothing but mgl by 2n square is your formula. Okay, is it understood? Is it clear? So this is the formula for pulling the chain completely on the table. Work done to pull the chain completely on the table. Okay, so these are some of the formulas for work done. Now if you understand the work done here, what is the formula for kinetic energy? What is the formula for kinetic energy? See here, if any body is considered, any ball is there, okay, which is present on a ground, which is present on a ground. So here, so initial velocity of the ball is 0. Let us consider the final velocity of the ball is v. The distance traveled by the ball is s. Okay, the ball was at rest. The ball was at rest. We have applied some force F and kicked the ball to move forward. Football was at rest. You kicked it. It starts moving. It gained some velocity, that is called as final velocity, and it has moved a distance s. Then what is kinetic energy? See, energy or work, both are same. Huh? Why both are same? You are doing work means you have got energy. You have got energy means you will do some work. A man having energy not doing any work is a dead body. Man is present, unable to lift one hand also. What is called as? It's called as a dead body. In home, if somebody died, dead body is there, all start crying. अरे हाँ मर गया रे मर गया रे चले गया रे ऊपर चले गया रे. One person will do one acting of crying. Girl, ladies will like मर गया रे मर गया रे. And that dead body, for 1 minute again life came, and he is telling, అంత ఓవర్ యాక్టింగ్ అవసరమా, అంత ఓవర్ యాక్టింగ్ అవసరమా అంటున్నాడు. ఏ షెడ్యూల్ again he died. For 1 minute life came. He said, భలే ఏడుస్తున్నారు కదా మీరంతా, అంత ఓవర్ యాక్టింగ్ అవసరమా, మళ్ళీ వచ్చి understood? So dead body is the only body which does not have energy. He is there but not doing any work. Understood what I am saying now? So energy is there means you will do work. You are doing work means energy is there. Yes? Okay. So hope you understand now. What is the formula for work done? See here, kinetic energy means work done only. So work done is nothing but force into displacement. Force is nothing but mass into acceleration into displacement. So here, a body which was at rest kicked gains a final velocity. You write v square minus u square is equal to 2as. From this, a is equal to v square minus u square by 2s. Acceleration formula you got. So what will you do now? So work done, which is nothing but kinetic energy here. So therefore kinetic energy is equal to mass, acceleration means v square, and one more thing, here it is 0, no? Initial velocity is 0, so acceleration is how much? V square by 2s. So how much you are getting an acceleration? So mass v square by 2s into s. So SS gets cancelled. So what is the formula for kinetic energy? Kinetic energy is nothing but half mv square. Kinetic energy is nothing but half mv square. So with this, in this formula, if you observe, what are the things which are constants, what are the things which are variables? See, mass is constant, half is constant, velocity is variable. So kinetic energy is directly proportional to v square. See, mass of a ball will not change. Mass of a ball will not change. Half is a number, it will not change. If at all something is changing, what has to change? Velocity has to change. So kinetic energy is directly proportional to velocity whole square. So with this, What is the definition of kinetic energy? The definition of kinetic energy is the energy possessed by a body by virtue of its motion. The energy possessed by a body by virtue of its motion is called as kinetic energy. Means the larger is the motion, the greater is the motion, the greater is the kinetic energy. Okay, I'll give an example. I'll give generally example, this example many times to understand kinetic energy. Huh? I have explained, a father has explained to his son, this is a bullet, this can kill a lion. Huh? This can kill a lion. So let us go for hunting. Both went for hunting. Son kept the bullet inside the pocket. Let us do lion hunting today. Okay, lion hunting. Okay. He saw, son has seen the lion, took that bullet, ran, thrown like this. Because dad said that this bullet can kill a lion. He thrown like this. That bullet fall on his head and fell down. Lion telling, what this fellow gilly gilly doing for me? With bullet, how can, if you throw in bullet, the lion will kill? No, 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 no. That bullet should be fixed inside the gun and it has to come with high speeds, 300 meters per second. Speed, if it comes, it enter into the body of a lion, then it will be dying. Just throwing with hand, lion will die. Nothing will happen to that. That means the energy possessed by a body by virtue of its motion, not this motion, that motion coming from the gun. The greater is the motion, the greater is the kinetic energy. So, to kill a lion, the bullet should gain such a kinetic energy that it has to enter into the head of a lion if it enters. If it is shot. Is it understood now? So, that is the formula for, what is this? Hmm? Hmm. So this is called as kinetic energy. Okay, understood what is kinetic energy now? Is it clear? So next, the most important concept is work energy theorem. Work energy theorem. What is this work energy theorem? Work energy theorem says that work done is equal to change in kinetic energy. Work done is equal to change in kinetic energy. Work energy theorem says that work done is equal to change in kinetic energy. What is this? What is the meaning of this? See, same as the old example. Already this ball is having a speed of 1 meter per second. You kicked it with some force. Okay. So once you kicked it with some force, it is moving forward. It is moving forward and it has gained a velocity of 5 meter per second. It has traveled a distance of 10 meters like this. Okay, its initial velocity is not zero now. Already it has velocity. See, football is already moving. Again, you kick it with some force. Its speed again increases. Its speed already 1. You kick it with some force. Its speed has increased from 1 to 5. Now, see here. V square minus U square is equal to 2AS. Here U is not 0. A is going to be V square minus U square by 2 into S. And you all know F is equal to work done is equal to force into displacement, which is nothing but mass into acceleration into displacement, which is nothing but mass. Acceleration means V square minus U square by 2S. Again, yes, SS gets cancelled. W is equal to half. Half comes outside. Half M V square minus U square. So this can be written as half M V square minus half M U square. So work done is equal to, this is final velocity, final kinetic energy minus initial kinetic energy. Okay, it's final kinetic energy, that is, this is initial velocity. So here initial kinetic energy, final velocity, final kinetic energy. So what is work energy theorem here? Work done is equal to change in kinetic energy. Kinetic energy change means what? Final minus initial. I think you understand this one. So this is the very important topic called as work energy theorem.